Hi, in this lesson 7C, we're going to learn about how we might want to combine data types. We've learned a lot of different data types. We've learned how to build classes. We've learned about ints and floats and strings. We've learned about lists and tuples. We've learned about sets. We've learned about dictionaries. We've learned how to build classes. There's all sorts of things we've been able to do. Now, what does real-world data look like? And how might we be able to come up with a representation of that real-world data so that we could do something useful in our programs? And the more complicated the real-world data, the more choices we've got. So let's get started and work through an example of how we might combine different data types. Now, we know that real-world data is often complicated. Suppose you had to keep track of all of the student course registrations for your school. Somebody found out you were now an expert programmer, and they said, "Can you help us build a scheduling system for our school? Why don't you start out with, here's all the data we've got about our current course offerings and the students and who's taking them, and what room numbers they're in." You might have access to a database that contains information about each student, about each course, about each teacher, about each section of each course, about enrollments in the various sections. Let's look at a diagram on the next page of what that data might look like. So, maybe I've got a database file for students, and it's got a field called name, and here's my names. I've only put 4 in. Your school probably has hundreds. Anya Artichoke, Baruch Banana, Consuela Cookie, and Divya Donut. I must have been hungry at the time I put this together. Emails for them. There might be other fields. There might be a student ID or contact information, or whether somebody is a freshman, a sophomore, junior, or senior, and so on. But you get the idea. We've got information that's unique to each student. Maybe we've got information that's unique to each teacher, like Ms. French or Mr. Cuban or Mr. I or Joe Cool. And these teachers have email addresses and perhaps some other information, like their address or their tax filing status or their salary or their room number or their phone number. And we might have some information like a course catalog. Maybe your school offers these courses: basket weaving, Python, and motocross. And there might be a description of each course, blah, blah, blah for the basket weaving, yada, yada, yada for Python, and super awesome for motocross. Maybe there's something having to do with, let's look at sections next. We've got 3 courses. Maybe some of them are offered at more than one time. That would be a section. So maybe I've got something that has a course, a section number. So I've got basket weaving section 1, basket weaving section 2. And Ms. French teaches it in section 1, and Mr. Cuban teaches it in section 2. And that happens in period 1, period 2 in these rooms. And maybe Python has 2 sections, section 1 and 2, and Mr. I teaches both of them, period 1, period 2 in rooms B and C. And maybe motocross only has 1 section. Of course, that one's taught by Joe Cool in period 1, and the room is the parking lot. And let's see then, how can we tie these things together? Well, maybe with enrollments. In basket weaving section 1, Divya is enrolled. In Python section 1, Anya, Baruch, and Consuela are enrolled. In basket weaving section 2, just Consuela. In motocross section 1, Anya and Baruch. In Python section 2, just Divya. Now, this might be how the data is stored in a relational database, and it's a nice way to store the data. But for you to do something in a program, like build a program that says, where is a student at any given time? Find me their room number. Oh, you might have to do something that goes through, looks for all of the students, for each one, checks to see if they're in any sections, and see in that section what period that's happening in and what the room number is. And so you could say from 9 to 10 they're in room A. You might have had to go through several of these things. How might we implement this? And let me warn you, there's many, many, many different ways we could implement it. It depends on how the programmer decides to put it together, what their style is. There are not really any wrong ways to do it. There are not really any right ways to do it, as long as it makes sense and represents the data and you can go through it. Some are easier to understand than others. Let's look at a few. We might have a series of lists of lists. Maybe we're just going to echo what was in our database, and we're going to have a variable called students that's a list. And in that list, each element is a list of the data for one student. Anya Artichoke, that school, or that email address. Baruch Banana, that email address, and so on. Now you'd have to know position 0 was the name, position 1 was the email address. I might do something similar for teachers. I might do something similar for courses. I might do something similar for enrollments. I might do something similar for sections. That's one way I can do it. Here's another way. I could use lists of dictionaries. So maybe students is still a list. See, I've got the open square bracket and the closed square bracket, where each element of that list refers to one student. But the students themselves are not a list. Each student is a dictionary with a key value pair. Name, Anya Artichoke, email, aa@school.edu. Name, Baruch Banana, email, bb@school.edu. Another student would have a name and an email, a name and an email. That might be a helpful way to represent the data. I might create a class called student, and that student class might have an init function, takes self, name, and email, and saves whatever you passed in for the name and email as self.name, self.email. Then the students might be a list where each element of the list was an object of type student. And I pass in this value. That might be a useful way to do this. Maybe I've got a list of dictionaries of dictionaries. Oh my goodness, it's getting complicated here. Okay, sections might be a list. Open the bracket, close the bracket down here. What's in the list? Well, the first element is a dictionary consisting of a course, a section, a teacher, a period, and a room. But the course wasn't just a name. The course was itself a dictionary, name and description. The teacher wasn't just the name and the email. Course here had the name, the description. Teacher had the name and the email. So I've embedded the data from a couple of those files into one place here, so that as I was going through the sections, I could figure out what's going on everywhere. This is a pretty complicated data structure, but it also means that the data structure is sort of self-documenting. You can maybe figure out what's going on if only you could work your way through that data. We're going to do some of that. We're going to call that data munging. Taking a look at data, seeing what's in there, seeing if it's in a format we want, putting it in a different format that's more useful. Our next video is going to go through an example of doing just that.